Maple is the essential math software tool for today's mathematicians, engineers, and scientists. It is the result of over 30 years of dedication by many talented people. In this video, you will hear from a few of these people and get a glimpse into the guiding principles that underlie Maple's development, making it what it is today.
Maple started as a research project in the 1980s. Initially, the focus was very much on symbolic computing and its use in education. Maple today incorporates both symbolics and numerics and integrates them very tightly. With that, also the range of applications has grown tremendously. Maple today is still very much used in math education, but it's also used in industry.
I think the most impressive thing about Maple is the size and the richness of its mathematical library. There are so many things that you can do with it. There are so many application areas that it covers. Everything from pure mathematics to sciences to engineering. There are tools for all of those applications inside Maple.
With over 4,000 mathematical functions and numerous options for high-performance computing, Maple can solve a wide variety of problems, but also extremely difficult ones. For example, users can use Maple to compute symbolic solutions to differential equations that no other system can match.
Maple concentrates, I would say, most things that you could find in the literature or textbooks, of course, but not just that. Maple also innovates every single year, bringing new algorithms. So if you have a differential equation and you're interested in an exact solution, well, if Maple cannot solve it, chances are that it's very difficult that you will solve it elsewhere. But you will probably be surprised that equations that you thought that were unsolvable, they are suddenly solvable in front of you in real time, rapidly.
The interesting part of our development work, and certainly of interest to a large number of our very sophisticated users, is that each release has new and powerful algorithms in it that go beyond what could be done before. The kind of things that we can now do in Maple with a couple of commands and calculate in a few minutes or seconds, they were unimaginable 10 years ago.
To ensure customers can take full advantage of the mathematical power within Maple, we've also put a lot of effort into Maple's smart document environment.
No matter how strong the engine is, no matter how many algorithms you have, no matter how extensive your library is, if people can't use it, if people can't get at that, you've got nothing.
Different customers use Maple in different ways, and we've designed a user interface to accommodate every type of user, from students to mathematicians to scientists and engineers.
One of the great things about the Maple user interface is that it really adapts to the way you want to use it. If you want to work in the natural math notation, you can do all of that without ever learning a single Maple command. If your application demands more complexity, or is a more complex application, you've got all the power of the Maple programming language there at your fingertips.
Maple lets you do more than find a solution to a mathematical problem. You can also capture all of your technical knowledge in an electronic form using Maple's smart document environment.
What I find most impressive about Maple and most useful as an engineer about Maple is the ability to do my development in the tool in this nice document environment. I do everything in one place, so I don't have a lab book anymore. I just do it directly in Maple. I don't have to flip over to another program to do plots, and I don't have to open a Word document. I do it all in one place, and then through a couple of commands or a couple of clicks of a button, I can get code out the other end.
Beyond code generation, Maple also provides connectivity to Excel, MATLAB, Java, C, Fortran, MapleSim, CAD systems, databases, websites, and more, ensuring Maple can be integrated seamlessly with your existing tools. Just as important as connections between tools are connections between people. Maple product features and online infrastructure support a passionate worldwide user community that shares experiences, techniques, opinions, and content.
Maple has fantastic tools for being able to communicate out to any community, however you define that community. Whether it be posting your material in the cloud, whether it be posting your content onto the web, whether it be publishing your content to a MapleNet server and allowing access to individuals online over the internet. It provides a wonderful environment for individuals to interact with whatever community that they need to interact with, whether it be their students, their peers, or with other researchers.
Our users go and many of them actually submit worksheets that they've created, which have some high-level, really cool, interesting applications. They submit it to the application center, and then any user can go in and just download the stuff and use it, and then tweak it and modify it and customize it to kind of suit your needs. The other thing is that you can easily share things through the Maple Cloud. So for instance, if I create a worksheet and I want to share it with my students, or if I want to share it with different coworkers, I can create this worksheet and simply with a click of a button in the tool, just upload it into the cloud, and then other users have access to it.
Over 30 years of development has already gone into Maple, and every day the developers at Maplesoft continue to push boundaries by developing new algorithms, new techniques, and new ways for customers to interact with mathematics and with each other.